Hi, everyone. Nice to meet you. There is Motion. Welcome to today Motion Control Quick Start. How to use oscilloscope function. As usual, we need to prepare these materials. And please wire them in this way. Here, controller or simulator. Then let's see what is oscilloscope. Actually, it is very important for program debugging and running. It makes signals as graphics. That is, showing data controlled by controllers inside as graphic forms. These data can be access parameters, access state, and so on. Which means we need to set the data to be captured. Firstly, open the oscilloscope. You can open through the view window or this shortcut directly. Secondly, set parameters in here, including data you need, scale, offset. Thirdly, determine your trigger method, manual or automatic. If you trigger it manually, you need to click Start, then click Trigger. If you trigger it automatically, you need to add trigger command in the program. Then click Start. It can be seen there are two parts of oscilloscope window. The left is data information. The right is graphic information. Okay, next, let's see data selection information at first. Here is the left part. It can be seen there are many buttons and options. Let's learn one by one. Click Config button. It will open Scope Config window. We'll talk in details later. Start Scope button. Obviously, it is used to start the oscilloscope, but not to open data capture. Stop means stop sampling. Continuous acquisition means it will not stop sampling when arrived set depth until click Stop. It is off by default. XY mode means it shows interpolation composed trajectories of two axes in XY platform, which means it shows in pairs. Curve 1 and Curve 2 are one pair. Curve 3 and Curve 4 are one pair. If this is not checked, horizontal axis means time, vertical axis means data. Actually, there are XY mode, YT mode, and XYZ mode. You can switch them as you need. This button is for hiding channel name, max value, and min value. Only channel number is shown. Trigger button is for manual trigger. If there is trigger command in program, no need to click this. Follow button means whether the horizontal axis follows the sampling position in real time. Show cursor is same as follow, but the object is cursor. If it is checked, when you move the mouse, the corresponding graphic will be shown. Show means whether current channel curve is shown. Index means the number. It can be axis number, I/O number, analog I/O number, table number, VR number, etc. Source is for data selection. There are many types. Select as you need. Offset, you can make the data move up and down. Then X scale and Y scale. You can set at any time. Okay, next, see the window under Scope Config button. In this window, you can set these. But please stop the scope firstly. Channel number means the number of data to be captured you need. It supports sampling 8 channels of data synchronously at most. However, when there are several channels, please attention that the depth can't be too large. Otherwise, table is not enough. Then depth means the times of sampling in total. That is, big depth, large sampling range. Space means the time space. Generally, it is system period, so it relates to controller firmware version. 1 million seconds is default. You can check it through servo period, and it can calculate the sampling time. For example, the depth is 10,000. The system period is 1 millisecond, and the space is 5. Space 5 means capturing one data each 5 ms, and captured 10,000 times in total. Then the capture time is 50s. Table pos means the data storage position, and it uses table end space automatically. This table space can be calculated. That is, multiple the number of channels and depths. For example, the controller table has 300s and 20,000s. There are 4 channels. The depth is 30,000. Each capture point occupies one table. so it needs 120,000 spaces. Then the starting position of table is 20,000. What's more, you can configure it, but don't repeat the space used in programs. That is, if the channel number and depth are the same as above, the table position can't be more than 20,000. Otherwise, it will report an error. For controller table space, you can view through the T-size command, or in controller state window, or entering *max command in output window. Backward means the background color for channels. Show type, there are points and lines. And here, left is the point type, right is the line type. It can be seen it is easier for line type to find the abnormal situation. So line type is more suitable for data with big changing range. Export parameters. If you need to export parameters, please check it. And when you check the button, after sampling, click Export. Then the data will be shown like this. In addition, you can import them again. In Stop State, click Import and select the file exported before. Then, all information are shown again, including all settings and captured waveforms. As we talked above, trigger is one command used in oscilloscope. In addition, there are two other commands. Number 1, scope pause. It only can be read for data captured and saved. That is, if captured already, returned value is same as depth. Number 2, scope. It is to save captured data into table. 8 types of data can be captured at the same time. These types are options in source. And here shows command usage. First parameter, enable. Second parameter, period. System period. Third parameter, table starting position for data saving. And this means table end position. All these are data types. There shows one example. Each 10 milliseconds, capture demand position and encoder speed, and save them into table. Table 0 to 499 is for position. To build 500 to 1000 is for encoder speed, and it spends 5,000 milliseconds together. Okay, from now on, all related information are introduced. Next, we will show 3 routines in ZDevelop for you. They are continuous trajectory look-ahead, electronic cam, and PSO position synchronous output. They will be shown in ZDevelop one by one. Before that, let's conclude how to use the oscillator scope. Step 1. Open program in ZDevelop and connect to controller or simulator. Step 2. Open scope window, do settings, and click OK. Step 3. Set number and data type. Click Start. Step 4. Download the program into controller. This program has trigger command. Otherwise, click Trigger in window. Step 5. Observe the waveform and adjust some parameters again, if not completed. Okay, now, let's operate them one by one. Open ZDevelop and open projects. It can be seen there are 3 programs. Connect. Run first one, continuous trajectory. Here, continuous interpolation is on. Set speed look-ahead mode as 2, corner deceleration, and set starting deceleration angle and end angle. SP is reference speed when in corner deceleration. Then run 1 linear and 1 circular motion. Open the scope window. Configure it. Select for channels. Set suitable space and depth. For data, we need position and encoder speed of axis 0 and axis 1. Then, start. Download the program. Trigger command is executed. Oscilloscope is capturing. Adjust the X scale for watching clearly. Here, mode can be switched. XY mode. XYZ mode. If you don't need corner deceleration, set the mode as 0 and start again. It can be seen there is no deceleration between two motions. The second routine, electronic cam. Save parameters into table. Use cam command to call table parameters. Open scope, stop it. Configure. 2 channels are needed. Show type is line. Choose export parameters here. Position and speed of axis 0. Start. Download. We can adjust the scale for clearing. Then click Export. Then we can import the data. Stop first. Click Import. Select it. It can be seen all information are the same. The last one, PSL position synchronization output. Comparison points are saved into table. Before comparing, delete uncompleted points. Then call position comparison output command. And if you need to learn this command, here is the help document. Search the command directly. Then it shows the corresponding introduction. English version, please contact us. First parameter is mode. Open the comparer. OP number. Op output state when arrived point 1. These 2 are table ranges. The last, comparison direction. Okay, open the scope. Set 2 channels also. Select encoder position and OP output state of axis 0. Start. Download to trigger it. Adjust the scale. It can be seen when the encoder arrives the first comparison output 50. It opens op 0 output. Arrive point 2, 100. Invert op 0. Arriving point 3, 150. Inverted again. Arrive 4, inverted. Until all points in table are compared. Then it stops. Okay, now 3 routines showing oscilloscope functions are over. Thank you for your watching. See you next video. Have a nice day.